I'm Francesc Campoy. I'm a developer programs engineer for the Go team in Monteview. And today I wanted to talk about Go. And Ina and Brian told me that you are into test development driven techniques. So I'm going to try to use TDD with Go to write a web app. So that's going to be the front end. And then I'm going to show how easy it is to expose a REST API using Go, and then consume it from the web part using AngularJS in 30 minutes. So that's going to be fast. 1 second. There you go. So we're going to start doing some live coding, and then to show a little bit how Go matches the TDD techniques. Then we'll build a REST API on top of that, and we'll deploy it. We'll show it how to deploy it as a standalone HTTP server, which is 3 lines of code, or on App Engine, which is 1 line of code. And then we'll show the UI and see a little bit the little lines of AngularJS that I wrote. So we're going to end up building this here. So it's an amazing to-do app, very original, right? Learn TDD, and it works. And you can put anything. I don't care. It's not going to be there forever. It will just wipe itself in a minute. And all the code that I'm going to be showing today, it's already on GitHub. So feel free to have a look. So we're going to start with this little thing that I guess all of you have seen. So what's TDD? TDD, what we do is, the first thing that we do, instead of writing some code, it's actually writing a test. And once the test is written, we run it, we see it fail, then we fix it. We fix it writing production code that fixes that test, and only that test. Then once we're there, and we are on the green side, on the green part, we're pretty much good. So we refactor the code to look better, and we then write a new test. We run it again, we look it fail, and so on. There's also a full state that I like to have there very often, which is think, between blue and red, which is what's the best next test to write. Okay? That actually helps you write good APIs for your package. So how do we write tests in Go? To write tests in Go, what we use is the testing package, which is part of the standard library. And it allows you to write functions like this. All tests in Go are functions that start with the word test. So here you're defining a function, test new and fail and fatal. So if you call any of those, the test fails in different ways. If you don't call anything, everything works. So here we can say, okay, we create a task. In Go, normally what we do is, instead of exceptions, we get 2 values, the task and an error. We don't care about the task. We're just checking that the error says something. So the error we expect to say, you cannot create a task with an empty title. If the error is nil, that means that it actually worked, so we fail. And then to run everything, all the tests, just do go test and the name of the package. You can also do go test, the name of the package, and 3 dots, and that actually means all the tests that are inside of that project. So finally, to run this every single time, that means that you write your test, you go, you run it, you see it fail, you go back, you keep on writing. And actually, it's something nice to have that being able to run the test continuously. Every time that you save, the test run again, and you see them fail or pass. So to do that, there's a package that I found creating this talk. It's called watch, and that allows you to do exactly that. You can do watch-t and a command. And every time that the directory where you're running that from changes, anything changes inside, it would just rerun it again. So, okay, let's do some live coding. This is going to be really fast. Okay. So we have this package that it's empty so far. We only have 2 files. Task.go, which is the production code, and task_test.go, which is the testing code. When you do go test, the code in _test is part of what you compile and run, so the tests are run. But when you do go run or go build or go install, everything, all the files that end with _test.go are ignored. So that means that you can separate your production code and your testing code really easily. So let's write one first test. So before that, let's make sure that we have not this one, no. Yeah. So everyone, everything passes. Why? There's no test. So yeah, that's easy. So let's start and say, okay, so we're going to test new task. So we need testing.t. And by the way, now when I save, there's something pretty cool. In Go, everything, all the import package, when you import something, you have to use it. If you don't import it, it fails. It doesn't compile. It's import what you use strict, which is a pain. Because when you save, when you have thumped to log stuff during your testing, every time that you remove it or put it back, you have to remove it or put it back from the import statements. So there's a tool called Go Imports that allows you to do exactly that. So now when I save, import testing appears by itself. This is really, really useful. So okay, let's say that I create a task with a title, learn Go. Go like this. And if the task.title is not learn Go, then we're going to fail, saying expected learn Go, got something else, and got task.title. Okay, so this is a test. Let's see. And it says it fails because new task is not defined. Okay, so by TDD, when you're strictly doing TDD, a compilation error, it's actually an error, and that's the way you have to do it. You first write code that doesn't even compile, and then you make it compile. So let's do that now. And we go here, and we define our function, new task, that gets a title, which is a string, and returns a task, whatever that is. And for now, we're going to return just nil. If we save this now, of course, it will say, I don't know what task is. Task is undefined, so we have to define task. And we say the type task, it's a struct that has a title inside, which is a string. Now, this fails even more. Why? Because there's a nil pointer. Of course, we're returning nil, and then we're checking that the title of something that is nil. Doesn't work. So let's just return a new task. If we do that, it still fails, but says expected learn Go, and didn't get anything. The title is empty. So we need to pass the title. So we have the title there, and now pass. Good. Now, let's do the second test. And this second test, I'm going to check that if I create a task with an empty title, that should fail. So I'm going to do task, new task of empty title. And so if you come from C++, what you could do is if the task you're getting is nil, it means that the task couldn't be created. Okay, so let's do that like that. So actually the error is the other way around. If we are able to create one task, that's wrong. So expected nil got this task. And it fails. It expected nil, and we got that thing, which is actually an empty. This is a very, very simple way to print. We could actually print something with more detail. And that will print, it got work.task with title empty. Okay? So let's fix that. Let's fix that. How do we fix that? So if the title is empty, then return nil, and it passes. Now, this is not the Go way of doing stuff. The Go way to do stuff like this, error handling, is to actually return an error. Okay? So instead of returning only one value, we're going to return two values. The pointer to task and the error. The semantics of this being, if the error is nil, then there's something interesting in the task. If the error is not nil, ignore the task. You shouldn't even touch it. Normally it's going to be nil, but could be anything else. Don't touch it. So we're going to do that, saying now instead of a task, we return a task in an error. So we're going to add errors.new empty title. And in the case where it actually worked, we return a task and no error, nil. Okay? Now, this doesn't compile anymore, of course, because a new task returns 2 values. And on our testing code, since we're refactoring here, our testing code should take this error into account. And if the error is not nil, fail with something like unexpected error, something like this. And now this should be, if error equals nil, then expected empty title error, but got some error. Okay, so let's see. And now it doesn't compile. Why? Because the same way Go is import what you use strict, it's also declare what you use strict. We're declaring this task variable here, and we're not using anywhere. This is probably a bug. So this doesn't compile. If you want to say, actually, I don't care about this value, you say, I don't care about this value, putting an underscore. And now when we save this, it passes again. Now I'm going to go a little bit faster and ignore the rest of functionalities of task. And let's go to how do we save a task. And we could say, OK, so I'm going to create a task the same way. Actually, I'm going to do some refactoring first. So it's going to be new task or fatal with the same thing, testing.t and a title. And this returns always a task. And it's what we're doing here. So that's going to be the title. And otherwise, return task, which means that now we can remove this and do new task or fatal with T and learn Go. Okay, so are we going to save this task? There's a lot of different ways of saving the task, but the way I was thinking about it is I want to have something that allows me to mock it later on. And I want to be able to say, save this task. And what I'm using is a type. I don't care about it. For that, you would normally use an interface. But that goes against TDD. Because that means that you're actually doing more abstract than you need at this point. So instead, I'm not going to do that. I'm just going to say, going to have a task manager. And this task manager, in my test, I don't care what it is. And I can save my task. That could return an error, and if the error is not nil, then unexpected error, an error. So now this doesn't compile anymore, of course, because new task manager is not defined. We define it. Task manager going to return nil so far, and the type task manager, it's an empty struct right now. I don't know what I'm going to put inside. I don't care. And this doesn't work because there's no method save. So we have to define a method save on the type task manager. How do we do that? We define a function that so it's a method. The receiver of the method is going to be the task manager. So we call it whatever we want to call it. And we say that it's save task and returns an error. This is the way you define a method on Go. And we're going to return nil. And our test passes. Is this good enough for our test right now? Yes. So this is how you normally do it. Which means that using TDD, this can be a little bit slow, but the result is that you end up having a pretty nice API. You end up having something that you've been thinking about slowly. And if you find out that your tests look weird, then the code that is going to be using your package is going to end up looking weird too. So this actually is something that, in my opinion, is something positive. So let's do last test. Learn Go and say, if I have a new task manager, and I save, so I'm going to do exactly the same thing. So save task and retrieve. And m.o, if I get all the tasks in the task manager. If we don't have one, expected one task, got something else. And then if the first task, which is the only one, its title, it's different of the title that we define, then also expect the title this, got something else. And expect the task dot title and got 0 dot title. Now this doesn't compile anymore because we don't have the method O. So we can define it, and the method O, it's going to be again O. It's going to return a slice of pointers to task, and we can return nil. Nil is it's a slice. It's an empty slice. So now it fails saying that we were expected to have one task, and we got 0. So something really simple to do is to return, when we save the task, we're actually going to save only that task. Our task manager is going to be able to handle only one task at a time. So we say, m.task equals task, and we return a slice of pointer to task, which contains only that task. And now this doesn't work. We have a nil pointer exception panic. The way to solve it is actually returning something. The new task manager is returning something that is nil. So we just need to return a new task manager. And there you go. We have a passing. And if we keep on doing this over and over and over, we ended up having something that looks actually pretty nice. So I did that, and I put that into this package. And with godoc.org, once you put something on GitHub or Google Code or whatever, you get a pretty nice documentation created for you automatically. So you get this thing where you have a task, and you have the method new task, which creates tasks, and then the task manager that has a new task manager that is kind of like a constructor. And you can do all to find all the tasks, find one task by its ID, or save one task. Okay. You can get all the description here with all the comments. Now, we're going to try to deploy this, actually to provide this task manager as a REST API. So then building tools that are using that REST API should be really easy. REST is something slightly complicated to explain sometimes, but basically what you need to do REST is two things, HTTP and JSON. Okay? So Go provides a very good HTTP package. It's actually the package that powers the download server for Google. So if you go to dl.google.com and download Google Earth, you're using some Go code behind it. And it's very simple. These 4 or 5 lines describe how to create a standalone HTTP server. So what we're doing is, on our main function, which is the beginning of our program, we say that we're going to handle all the requests going to / and everything that is under that, so all requests, with add handler. And then we just start listening to that. And add handler, it's this method that's an HTTP handler, that's a type. And it has two parameters. The first one being a response writer, where you write the response. And the other one is a request. So basically what you do is you get data from the request and you write into the response. Now, that's only HTTP. But for REST, you're going to need to use JSON inside. So the standard library also provides a JSON package that, using reflection, is able to do encoding and decoding in a very, very easy way. So now we're creating the first line. We're creating a variable, rec, for request. And what we're doing here is saying that the type is an anonymous type. It's a struct that has two fields, A and B, which are integers. And we don't put any values inside yet. And we create a new decoder, reading from the request, from the body of the request, and we decode into that request. So if that fails, that means that the request that we got was not what we expected. Maybe we have some wrong field, so it's just not JSON, or maybe it's empty. In that case, we say, okay, we failed, HTTP error, and we say that the status is status bad request. That request was wrong. Otherwise, we create the result, and the result is, again, a struct that has only one field called result, which is an integer, and we initialize it to be the sum of the two values that we got in the request, and we encode it. Now, if we encode that, so we're encoding it into the response, okay? And if that fails, that's not a bad request problem. That's our problem. Something that we did is wrong. So in that case, we're going to log an error and say, whoops, or print, show a flying whale, or whatever you want to do, and status internal server error. It's like something failed. We don't really want to tell you what failed. So this is the whole code. I added just a little thing saying that if it's not paused, I want people using my REST API. This is not really REST, but this is an example. I don't want people using this with get, only paused. And if they do, that could be status method not allowed. And there's a run button here, which is there. So if you run that, now I'm running my HTTP server. If I do a get on that will fail, saying get not allowed, and with a good status code. And if I run this, so this is actually not good. Let's put first the one that works. So if we do 1 and 2, that's bad request, of course. Oh, there you go. Thank you. So result 3, yay, easy. And as you see, if you write something that is not correct JSON, that's a bad request, so that's good. Of course, if you put something which is also like hello, that could still fail because you're trying to decode something into an integer. Where is this information coming from? The fact that we have A and B, which are of type integer? That's just because we are declaring request as being a struct that has two int fields A and B. If you want to have something different, some different names, we have field annotations that allow you to do exactly that. So you can say, actually, A, I wanted to call operator number 1 in the JSON object instead. You can do that. So how do we do what we had before? How we do expose the API that we had before as JSON, as REST? So using Gorilla Mux, this web framework, actually web toolkit for web development in Go. It has this mutex, which it allows you to define routes and handlers for the routes given a single method. So you can say, okay, so if I get a get method on the path prefix, which is task, so if I get a get on task, I'm going to list all tasks. If I get a post, I'm going to create a new task reading something. And if I get a get on the path prefix with a task ID, I'm going to return only that task. And if I get a put with that task ID, I'm going to update that task. Okay? So pretty much REST. And then to just say that everything in HTTP is handled, if it comes under task, whatever, it's handled by that route. Now, how do we do the list all tasks? Knowing that we have tasks, it's a task manager as before. So we have the method all. So we declare a response, which is a struct that has one field tasks that is of type slice of pointers to task. And we put that list of tasks inside, and we encode it. That's it. That's everything we need to do. How do we do the post? How do you create a new task? So for the post, we're actually requesting to read a JSON message that contains one field, which is the title. So that's exactly what we say. We have one field called title, which is of type string. We don't initialize it yet. Instead, we decode from the request body. If something bad happens there, the request was bad. Not our problem. Then we create the new task. If something bad happens there, that's still not our problem. Probably the title was empty. So we still say bad request. And otherwise, we save the task. If something fails there, our fault. In that case, it's going to be handled by the framework and say it's HTTP, so internal server error, something like that. Now, once we have this REST API, building a UI on top of it, consuming that REST API, is something that is really simple. So we're going to build this that allows you to list all the tasks, create a new task, and toggle the done state for a task. Okay, pretty simple. So get task, that's post task, and that's put on task with ID. Okay, 3 methods. And that's all. That's not all, but that's enough, let's say. So using AngularJS, you have the HTTP resource. No, HTTP, I don't know what's the name of that, because there's resource too. HTTP thingy. You can do a get on task and say, if the function is successful, I'm going to update my scope.tasks. And then this list, it's actually a repeated statement on that variable. So when you update scope.tasks, magically, you have this double two-direction binding. You will get the HTML updated for you. And otherwise, if something bad happens, you log the error. And if you want to set this task to be good state, what we're doing is we're creating this new task. Instead of changing, so I did it 2 ways. The first one is I changed the state on the task. So task.done. This line here, task.done is equals the not task.done at the beginning, which means that I update the task on the UI, then I send the post. If that fails, that means that at some point I'm going to have to go back and say, whoops, sorry, no, actually this didn't work, and the task is still not done. So instead I change that, and I create a new task, which is not linked to the HTML yet. And what I do is I send that new task which has the task done, which is the opposite of what we had. And only when that works, I change the UI. So if you have a very, very slow connection, which is, I discovered this using it with my phone on Verizon. So you will see that actually you click, takes a little bit, and then it checks the task. So with that, we're only missing the little fact that all of that, now we have something that is able to handle our REST API and something that handles the web UI. How do they put all of this together? So I defined this register handlers method that it's actually what we're going to do. It's part of our server, and what it does, it registers all the API methods on HTTP package. Okay, so when you call this method, it means, okay, I want for this binary that task anything is not handled by me. It's handled by the to-do package. And then for the rest, if you access anything else, I'm going to be serving from the static directory. And the static directory is the one that contains CSS, JavaScript, and HTML. And then listen and serve. And that's it. What about on App Engine? On App Engine, there's no main function. Well, there's the main function, but it's not up to you to write it. And you don't have to start listening. That's everything that an App Engine does. So you don't have to do anything. You just have to register the handlers. And what about the static side? you define on app.yaml. So what you say is, if there's anything coming as task, whatever, that's going to be handled by my Go application. If there's just the root, I'm going to handle showing my static index.html. And otherwise, I have the static directory, find it there. Okay? So something that's interesting is that everything that we wrote here, it's working only in memory. Okay? We're not saving anything anywhere, which means that if you restart your server, you lose all the tasks, which is not great. Especially if you're doing it on App Engine, because on App Engine, tasks instances are dynamic, which means that if you don't get any requests for a while, the instance goes down, and when you get a new request, you get a new instance with no tasks. So if you wanted to do this, probably what I could do is, if we check go.org, this task manager has 3 methods. That could be an interface. You could create an interface that has exactly those 3 methods and then have different implementations of that. So you could have, for instance, the in-memory that we created for testing. You could have something that writes something into a MySQL database if you're running as a standalone server. Or you could have something using the App Engine app store, that data store, sorry. So I think yeah. So wanted to show you one last thing. Okay. So I want to show you, this is the static, and I don't know, how many of you have used AngularJS before? Okay, so I'm going to get into a little bit of detail here because I think I haven't used much AngularJS, and I think it's really cool that it's really, really simple to use. So we have this is all the JavaScript that I wrote, and knowing that I don't like JavaScript, I'm happy with that. So we declared this controller that has some objects, and I have 2 things. The tasks, which is the list of tasks, and working, which is a Boolean, which is, am I doing something right now, or I'm just waiting for something? I'm waiting for the user to do something. Then we have, these are private functions, let's call it like that. One of them is refresh. Refresh, what it does is it does the get on the task URL, meaning that I'm going to obtain all the data, which is actually a JSON object that contains one field called tasks. So actually, it's pretty cool because the encoding and decoding of JSON on the JavaScript is done automatically, of course. That's JavaScript, and JSON was done for it. But it's actually very similar to what you do with Go, except that in Go, you actually have to declare those fields to be somewhere. So you declare it on the inside of the struct. So we update this, and that's it. Adding a to-do is pretty simple. Well, not really, really simple because of callbacks. So if you are used to doing callbacks are nice. If you come from Go where callbacks are not something that you use, instead we use concurrency and channels and Go routines, these lines were actually kind of difficult to write for me. But basically what you say is you do the post, and when you do that post, if that post fails, you fail. Otherwise, if that works, then you do refresh. So you update the list of tasks. And once you do that, afterwards, even if it works or it doesn't work, you say that you're done writing, and you empty the to-do text, which is actually the field for the new task. And toggle done is, as I was showing before, just create it and call the function. And then on the HTML, everything that you say is, my list is actually repeating on tasks. So tasks is that scope.tasks. And I'm showing the title. And then new task, when you click, it calls add to do. So it's really, really simple. And I think it's definitely worth trying if you have to write a web app AngularJS, I think it's pretty awesome. I don't work for the AngularJS team. I just don't like JavaScript, and AngularJS allows me to stop writing JavaScript so much. So that's awesome. And Go for the backend, I think it's also a very good option. So next steps, you can learn more Go, so golang.org. If you want to learn Go without installing any compiler or anything, there's the interactive tour. It's very useful, and it takes you from how to declare a variable to how to write a concurrent web crawler. And then for the code that was here today, there's also a link to the slides. So you can see the slides again if you want. So thank you very much. And now we have some time for questions. So anything? Yeah?
I've always ended up passing the pointers to the structs that,
So I do that because I prefer it. It's really an option. I don't, in all the code that I showed, actually let me go to the code in here. So on the task, here, for the task, it couldn't change anything. And for the task manager, it could actually change the fact that I have a last ID. And if this was not a pointer, you're actually calling a method on a copy of the object. Okay? So if you're modifying that object, you have to pass a pointer. If you are not modifying it, you could pass a copy. But then, if you're passing a copy, if the object is very, very big, maybe you don't want to pass. Be copying all around all the time. The compiler, depending on which compiler you're using, optimizes those copies away. But it's something that you shouldn't trust all the time. Like it's something that's really easy to say. And finally, if you define one method on a pointer, it's a good idea to define all the methods on the pointer, so you don't have to remember how it works. So normally what you end up writing is these kind of things where you do a new task manager or new something, and you return a pointer and an error, and then all the methods work on pointers. That's the normal case. Yeah. Anything? Yeah?
How did you test drive the web server part?
How what?
How did you test drive the web server?
So to test the web server, that's why I have this server.go that uses HTTP and all that. Actually, there's a HTTP test package that allows you to create fake HTTP servers in memory, and then you can actually send a request and check that the response is what you expect. And especially having a REST API, it's very easy to do, because you can actually just have your JSON objects there and say, if you send this, the result of decoding this should be that, rather than comparing strings, which can be painful, because maybe there's a space in there that you didn't expect. For the App Engine part, if you're running things on App Engine, I imagine that you want to test something that is using the data store. There's GAE test that allows you to do that. So it's like a test context for App Engine. On App Engine, all the operations are based in a context. So if you've not that, then you can test everything. So we have that too. Yes?
Are there patches for the test? It seems like a lot of the things you're calling to fail directly.
There's definitely frameworks to do that. I don't really see the need, personally. But we have a very active community, and every time that you have someone from a language that has a very, very successful framework and moves to Go, we write those frameworks in Go. So you can definitely find mostly every single one in Go, yeah. I think it's better to write the test like this, because you end up having more fine-grained errors that help you understand what failed. Okay, so thank you very much. And if you have any other question, I forgot to write my email, but it's Campoy, like my family name, at google.com, or my Twitter, Francesc. Okay, thank you.